Hello everyone, welcome back to one more session of multimedia system. Let us continue our discussion with the topic data compression. In the previous session, we had discussed about the MPEG, the lossy technique, and also we have discussed about the frames like I frames, B frames, P frames, D frames, and we have seen the audio compression with respect to MPEG technology. We had also discussed about the MPEG audio coding diagram in detail. Let us continue our discussion with the data compression of MPEG. When we talk about MPEG, it is Motion Picture Expert Group. It is a standard for encoding video, movies and the motion pictures. MPEG has a video extension with the MP4. When we talk about the MPEG, it has two components. One is the audio, where we have discussed about the compression of audio in the previous session, and it also comprises of video. So, whereas MPEG is the encoding for videos, motion pictures and movies, it comprises of two components. One is audio and second one is video. When we talk about the extension, the audio extension with respect to MPEG would be MP3. Okay, and with respect to video, it would be MPEG-4, that is MP4 technique. Okay, these are the two extensions we use during the compression of MPEG. Now, when we talk about the evolution set, the various standards has been evolved with respect to MPEG. When we talk about the evolution of MPEG, it was MPEG with respect to MPEG 1, 2. So, MPEG 1 and 2 are most popularly used. We have 4, 7 and finally we have MPEG 21. So these are the different standards of MPEG. As we know that it is a lossy video compression technique, but the compression rate is very good with respect to the MPEG. When we talk about the compression, it is with respect to both audio and video. We achieve a very good compression rate for both audio and video with respect to the MPEG, whether it might be whatever the standard. Here we apply the similar techniques as that of JPEG for still images. When I talk about the moving pictures and other things, we have different frames where some of the frame constitutes of the still image, that is a stagnant, that is stationary pictures, which is similar to a JPEG. So in those cases, we use the application technique with respect to JPEG. We have seen the compression of JPEG in one of the sessions. The same technique could also be deployed here with respect to that. Now, when we talk about the MPEG, let us look into the compression steps. Here it's a core part what we are about to deal with that. So MPEG compression steps. The whole MPEG compression can be categorized into 4 major steps. The first one is the data preparation. The second one is the data processing. Where in the second step with the data processing, we deal with motion prediction, and we also deal with the DCT, applying of DCT. The next one is the third. So third process or a step is the quantization. The fourth one, entropy encoding. So we'll look into each step. When we talk about this, the steps of a compression, it is very beautifully represented like the process. Step 1, the step 2, the step 3, and finally the step 4. So data preparation is followed by the step 2, that is the data processing. The data processing is followed by the quantization. The quantization is followed by the step, the entropy encoding. Now when we talk about this data preparation and all these things, which is similar to the preparation with respect to JPEG. So let us look into the step 1. When we talk about data preparation, there are number of signals that we encounter with respect to MPEG. So we classify those signals into sub-sample chrominance signal. Okay. Sub-sample chrominance signal. Okay, we divide the lot of signals into sub-sample chrominance signal. When we talk about this, we are classifying the sub-sampling signals in the ratio of 4:1:1. So what is this 4:1:1? So we have two standards of MPEG. One is NTSC and second one is PAL. So we'll look into it first. So when we talk about NTSC, we have Y of 352 into 240 and the one more resolution of 176 into 120. We'll discuss what are those. Next, with respect to PAL, we have 252 into the ratio of 288. The CBCR is equal to, here we'll see 176 into 144. So what are these? This is the one part. See, when we talk about the ratio, this ratio 4 is pointing towards Y. We'll see what is Y. And this one is pointing towards the one of the components of CB. And one more ratio 1 is pointing towards the one of the component CR. So what does CB, CR and Y mean? When we talk about the Y, it is a luminance information. It is luminance factor. So when you talk about the luminance, means light. It stands for light. So what is the amount of resolution of light we obtain? It is 352 into 240 resolution. And what about CBCR? CBCR are the two chrominance information. What does this chrominance information have? It consists of the properties of the color. Chrominance means the color. It consists of 176 into 120, whereas PAL has a 176 into 144 resolution. So what are these two standards? These are the two predominant standards used in the world, whereas the NTSC standards is used in America, where we in India use the PAL standards with the luminance factor of 352 into 288 and with a chrominance factor of 176 into 144 resolution. This is about the first stage. So what we do here, when we have this resolution, here each frame is divided into the macro blocks. So since we have lot of samples, here also we divide each frame into macro blocks. Frame is divided into what? We call it as macro blocks. When we call about the macro blocks, it is 16 into 16 samples for luminance. I'll write it here. And for chrominance, we have 8 cross 8. Means where this macro block associates or supports 16 cross 16 samples of luminant component and 8 cross 8 samples of chrominance component. So what is this macro block? Suppose, let us consider this as an image, a person. So let us consider this stickman itself. So this frame is totally divided into 8 cross 8 matrix. Look at this. So we have seen the stickman was a frame, and that frame is totally divided into 8 cross 8 sections. We call it as macro blocks. So which supports the color factor of 8 into 8 segments and the brightness or the light signals of 16 cross 16 resolution. So in the first stage, what we do in the data preparation, we prepare the subsamples of chrominance signal, mainly concentrating on the chrominance, where each frame is divided into the macro blocks. So with the property of luminance supporting to 16 cross 16 and the chrominance supporting for 8 cross 8 resolution. This was about the stage 1, that is data preparation, which is similar to the data preparation as that of JPEG, which we have discussed in detail. Now let us go into the stage 2, that is data processing. So what we do here in the second stage? In the second stage, we apply the motion prediction. So since this category of MPEG comes under the prediction category, we apply a prediction at the macro block level. So these are called macro blocks. At each frame, different blocks will be there. So we apply a prediction at the macro block level, where we identify exactly where motion is happening, because see, if the still image is there and there is a sequence of motion, there is no meaning in compressing those still images. We are supposed to identify the motion frames so that we can compress those things, because motion frames are the continuous frames. If we compress those continuous frames, we will be able to reduce the size of an moving pictures. So we, in the first stage, we use the prediction methodology in order to identify exactly where the motion is happening, because we change the data only where motion is happening, or in other words, where we are concentrating for compression where the motion is exactly happening. So first step, here we apply the prediction, and we identify the frames where exactly the motion is encountered. In the second level, in most cases we see that prediction encoding only makes sense for parts of the images with motion and not to the whole images. So here when we talk about these kind of frames, mainly in main cases we apply, or it makes a sense for applying the prediction methodology and the compression only for the images with the motions. If a still image is there, it is very good as JPEG compression. So we are concentrating on MPEG, that is the motion. So we are identifying the motions, so in order to apply the compression technique. So motion prediction is used to figure out where this macro block may be in the next frame. Means, now look at this, this is one frame, a stickman holding a hand like this. In the next frame, there is a possibility the stickman moving his hand slightly. In the next subsequent frame, moving one more down, and the subsequent frame like this. So when this frame is continuously played, we get a motion like the stickman holding his hand like this is been continuously moving. Or this hand, look at this hand. In the first frame, the hand is like this. I wanted to wave you. So in a video, you might see a motion picture like this waving. But what happens here? There is a continuous sequence of motion pictures, that is the frames. In the first frame, the hand might be like this. In the second, slightly. In the third, here. In the fourth, here. And the fifth, here. And finally, like this, like this, like this, and the back. So these continuous frame like this constitutes a combination of very different individual frames in which the whole part is stagnant, only the hand is moving. So we are supposed to identify those frames, and the prediction is made where would the hand go next. So where would the next, and what is the next, and again reverse, vice versa. These are the predictions we do with respect to MPEG in order to do a compression. Otherwise, there is no need of compression itself, because if it's a still image like this, hand not moving, there is no need of compression. We take a single still picture and it can be used with less storage space. So in the second stage, we prepare the processing after the preparation. So what we do here, motion prediction is mainly done. So what is motion prediction? We just saw it. So here we have three kinds of prediction. First one is forward prediction. What is forward prediction? So forward prediction is based on the previous frame. Means we look into the previous frame and predict what would be the next frame would be. Means like here, if suppose I wanted to wave like this, my hand is like this, I analyze this frame and predict in the next frame the hand will be moving slightly this. So this kind of prediction is said to be the forward prediction. The second kind of prediction is called the backward prediction. So here in the backward prediction is totally based on the future frame. So we call it as like a backtracking. Suppose my motion hand has to be waving. So here what I do, this would be the this would be the end level where my hand is supposed to come back and wave like this. In particular cases, we use the current frame and analyze what was the previous thing or what could be the future thing also. So this kind of prediction is said to be the backward prediction. The next kind of prediction is bidirectional prediction. So we have seen the forward prediction and the backward prediction. A combination of both is said to be the bidirectional prediction. Here the prediction is based on both the previous and the future frames. Sometimes we analyze the current frame and we try to assess what could be the next frame. Suppose in particular cases we use this current frame and we can predict what was the previous frame. So this is called backward and the previous one was called the forward. The combination of both kind of prediction, what would be the what was the previous and what would be the next frame is said to be prediction is said to be the bidirectional predictions. So when we talk about these things, so the forward prediction, backward prediction and the bidirectional prediction, we need to know a component called the frame itself. So what are those frames? What are the different types of frames that needs to be analyzed? In one of the previous session, even I have given a good glimpse of information with respect to the 4 types of frames, that is I frames, P frames, B frames and also D frames. So I would like to highlight those importance because we are actually concentrating the concept of frames here with respect to these 3 properties. So we call it as IBP frames. So let us look into the IBP frames. The first one will concentrate on the I frames. So what are I frames? We have already discussed. So we'll summarize it in short. So I frames are said to be independently coded and no temporal predictions. Means these frames are very independent. These are also said to be the independent frames because these frames do not rely on the previous or the future frame. These are exactly the still images and there is no temporal predictions. So when you call it about no temporal predictions means after a few seconds it might change or it has changed over the period of time. No, those concepts will not be applicable here. These are totally still and we can start decoding once we have iframes because these iframes are totally stagnant still. So there is no need of processing. We can directly start decoding with those frames. These are independent frames. These kind of frames are said to be the iframes. Next is the P frames. So what are these P frames? P frames are said to be the forward prediction frames. Look at this. This is why I started telling you about the frames. So P frames are said to be the forward prediction frames. What do you mean by forward prediction? We have discussed here. Based on the previous I or a P frames, this can be done. Means this P frames totally relies on the I frames or the previous P frames. Means when we encounter P frame, there should be a previous I frame or it might be a one more P frame. So these P frames are not independent. So they rely on some other frames. What are those frames? It might be I frame or one more P frame. So whereas this I frame is totally independent. That's why this technique is totally said to be a forward prediction frames. Next is the B frames. When we talk about the B frames, these are the bidirectional frames. Because I tell you why P frame, why I am not talking about the backward. When you know a particular frame, you can go with either forward or a backward. Suppose you have 3 frames like this. If you know this or if you are having this, you can predict what would be the future or you can predict what was the previous frames. So this is the importance of P frames. Next, when we talk about B frames, so B frames are very much suitable when doing the bidirectional assessment. So it is also referred to as bidirectional predicted frames based on the previous and the following I or a P frames. Means when I talk about B frames, like P frames, there should be either B or a I in the adjacent stages. This is about the 3 frames. Next, we have group of pictures. Which is referred to as GOP. In short, it refers as GOP. What is GOP? Group of pictures. A set of frames between I frames is said to be a group of pictures. Means there might be I frame and there is one more I frame. In between there would be n number of different frames, and that set of frames from I to I, in between there will be a lot of frames, and that frames are said to be the group of frames. For example, I write here is I frame, there are two B frame, a P frame, B frame and I frame. Look at this. Now this is said to be a group of frames. So combination of all these things is said to be a group of frames. One more illustration that can be considered, I frame, and I have a 3 P frame and an I frame. So again, see, at the start and the end we have I frames. In between we are not bothered what kind of frames we have, but there are frames. So that kind of grouping is said to be a group of frames, or it can also be a combination of only two I frames. Then this kind of thing is said to be a group of frames. So this would happen with respect to the stage 2. So when we are dealing with MPEG decoder, many times it needs to have a buffer, because an extra frames of data being added for the displaying property. Means during the process of this, that is a processing, we need to have an extra buffer, because we are calculating about the previous and the future frame. So in order to make a good display property, a temporal space is needed during the process of decoding the frames. So a good buffer or a huge buffer is always suggestible. So next, see here we have predicted with respect to in the motion pictures how the frames have been assessed during the moving things. So in the second stage we apply DCT. What is DCT? That is, we have already gone through the discrete cosine transformation. We mainly apply DCT to reduce high frequency component and retain the low frequency component. Means what we do here, there are two kinds of components which has been already discussed with respect to the audio technology in the chapter 2. So what are those? We have two components, that is AC component and second the DC components. So what we do here, we reduce the high frequency. What are the high frequency? AC components are always said to be high frequency components, whereas the DC components are said to be low frequency component. So the main intention here for applying DCT is to reduce the high frequency component in MPEG and retain the low frequency component. In other words, we apply those DCT on this 8x8 blocks, because in the first stage itself we have prepared, in the second stage we have predictions made, and now we apply this DCT component transformation on these kind of blocks. So the DC component consists of lower or sometimes a constant frequency component. Why do we call it as constant frequency component? Is sometimes it consists of I frames which are constant still images. So we retain that and we try to exclude the high frequency component, that is the AC component, which consists very high frequency range. So next, so our main aim here is to remove the high frequency. So here by applying the DCT, we will be able to achieve by the concept of removing the AC component. And we'll look into the third stage. In the third stage, it is said to be the quantization. You know that what is quantization? The process of quantization is to group a similar category into a group kind of things. A similar kind of signals are made into one group, like 3-bit quantization, 4-bit quantization, 8-bit quantization, 16-bit quantization, and so on, like 32 and so on, different group of quantization. So what we do here, we apply the quantization process on the frequency domain coefficients, because there are different coefficients. I have shown you how the 3-bit to 16-bit and 8-bit quantization has been done using the sine wave. So that same process is being applied here. To favor the lower frequency coefficients, we remove higher frequency coefficients. So by using the quantization, we group it, because in the previous stage we have been retaining the lower frequency coefficient, that is DC coefficient, So we group those coefficients as one component. What is the meaning of that? The meaning of it is we are excluding the higher frequency range, that is the AC component. So grouping on DC frequency coefficient is the main intention of quantization, because we want to exclude the AC component thoroughly. So it requires minimum data to represent the given video range, because we are using the process of quantization to exclude the higher frequency range, that is AC component. So DC components when are used only to represent, obviously what happens here, the size is totally reduced. Means if there are 4 things like this, we retain or we delete the higher frequency range and retain the DC coefficient, that lower frequency range, and quantize into group. So combined we have the storage been reduced, means lesser data we have, so that the representation of data becomes very less. Obviously the storage or the size of the video becomes very less. So fourth one, when the storage is less, we need to encode it. That is the fourth stage, that is entropy encoding. So what we do here? So usually we convert the 2-dimensional symbol. Look at this. This is a 2D representation, one and the other face. So we call this as 2-dimensional pictures. We have the vertical axis and the horizontal axis. So both the things. So rows and combination of rows and columns. So these kind of picture representation or frames are said to be 2D. What we do here in the entropy coding, because we need to apply the algorithms for the efficient utilization. So what we do first stage in the entropy coding, we convert these 2D dimensional symbols into 1D series, that is 1-dimensional, that is 2-dimensional data is converted into 1-dimensional data. This helps to apply the algorithm effectively, because it's very difficult to apply the algorithms on 2D data. So when it is 1-dimensional, it is easy to apply and get an effective result from the matrices. So how we do it? So we apply the algorithm, we apply it with zigzag or vertical scanning. So I have shown you how the zigzag and the vertical scanning do happens. So here the zigzag scanning and the vertical scannings are the 2 methods used, but usually like that of JPEG, the zigzag scanning is very much preferred. How does this zigzag scanning works? Let us look into it. In order to represent that zigzag pattern, we need to have the matrix of 8 cross 8 frames. We have 4 by 4. Now I will reduce it in order to make it as 8 cross 8. Now we have a frame with 8 into 8 matrix section. We have 8 rows and 8 columns. How does this zigzag movement happen? So when we call about zigzag movement happen, see here from this point to this point and come back here from 1 to 2, again go back here 1 to 2, again come back 1 to 2, again go back here 1 to 2, again come back here 1 to 2, again go back here 1 to 2, again come back here 1 to 2, again go back here 1 to 2, again come back here 1 to 2, again 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 here 1 to 2, and so on. See, look at this. By this kind of movement, we have complete zigzag motion recovered. So this is called a zigzag scanning. Now when we apply this kind of pattern to a matrix with the help of a run length coding, on one-dimensional data. So when I talk about one-dimensional data, I'll wipe out this. Let us consider the matrix like this. Suppose you have a matrix with the first element as 100 and the second element as minus 60 and third as 0 and the fourth as 6 and so on, it's zeros. So instead of writing all these things zeros. So I'll take up this as 1, 2, 3 zeros and write it as 13 here and followed by 3 zeros. So 1, 2, 3, 4, 1, 2, 3, 4. So 8 elements are there. Again here I write 3 zeros and beside the 13 I write minus 1. All remaining elements to be assumed to be 0. I don't write it, just for your understanding I'll make up this. So how does the zigzag scanning happens now? So consider this is the value of a frame. Now this is the frame. So these kind of value will be there in each frame, in each block of a frame. So we scan this. So the scanning happens like this. Look here. This process goes on here like this. And goes till the bottom. Now when we do up this kind of scanning, we will be able to get a long listing of sequence. What does this do? I'll write it here itself for the better understanding. See, the first representation can be represented as like this. What does this mean? So we are converting the 2D into one dimension, where here see 100, before 100 how many zeros are there ahead of 100? Means I wanted to represent this value in a one dimension. The best method of representing this value in a one dimension is how many zeros are ahead of 100. There is no zeros, so I write it as 0. Next, what does the 7 represent? The 7 represent the bit required to represent 100. Means how many bits are required to represent the 100. So that is 7. And what is the value? What are we trying to represent? 100. It means there are 0 number of zeros ahead of value 100 and 7 bits are used to represent the value 100. So this is 1. Next we have the 6 here. See, look here. When we go up like this, the next value here after 100 is 60. That is minus 60. How do we represent? We represent like this. We represent like this. Means, what does it 0 represent? How many zeros are ahead of the values minus 60? See, there is no zeros, but there is a value which is not 0, which is 100. Okay, so which is not 0, so there is no zeros. So how many bits are used to represent the value minus 60? 6 bits are used to represent. So what is that value? That is minus 60. In this way, we would be able to convert the two-dimensional image into a single dimension. This goes on like this. So that's why we use the zigzag pattern. Like with the way we moved out, we completely traverse the whole path and write the representation in a single dimensional equation. So then we get a totally compressed image. Okay, this is how the MPEG compression of MPEG happens. The first is the data preparation, which is almost similar to that of JPEG, and second, the data processing. In the data processing, we mainly concentrate on the motion prediction, where I have seen we have discussed about a different prediction with respect to frames, that is I frames, P frames and the B frames, along with the properties. And the group of frames between two eyes is said to be GOP, and we apply the DCT here, that is discrete cosine transformation, to those signals. So in those signals, during the process of quantization, we try to eliminate the higher frequency component, that is the AC component, and try to retain the lower frequency components, that is the DC components. So when we have those DC components, we will be able to get a matrix like this, or a macro block like this, which is in the dimension of 2 cross 2. It is very difficult to apply the algorithms on two-dimensional matrix. In order to apply the algorithms like run length and other thing, we convert the 2D during the process of entropy encoding into one dimension. So to convert those 2D into 1D, we use the common convention method, that of JPEG and MPEG, that is a zigzag motion of scanning, how the scanning goes out. In the similar way as with scanning goes on, the same traversing method is used in order to represent the equations or values with a one-dimensional value. This process I have stopped for only 2 values, it goes on till the last value. And finally, we would be able to get a single dimension of matrix which has been totally able to represent the whole motion picture in a reduced size. This is how the compression of MPEG happens. So then let us see what are the advantages of MPEG, why it is so important. In spite of lot of steps, we concentrate on MPEG conversion. It produces a very good quality results with different compression levels. So this is important, and it is compatible with web browsers. Yes, this format is very much suited with any of the browsers, and one more thing, it is very much compatible with most of the media softwares. Means most of the softwares would be very easy or comfortable for playing these MPEG videos, and it has better quality than the AVI standards. So these are the main aspects of MPEG. So while summarizing what we have discussed in this session, we have discussed about the introduction about the MPEG. We have seen the various standards, the MPEG 1, 2, 4, 7 and 21, and we have seen the MPEG compression steps, the 4 steps we have gone in detail, and we have also discussed about the advantages of MPEG. These are the topics I had wished to share in today's session. Thank you very much.